Hello, everybody. I hope you accessed your notes on percent composition. We are continuing again with chapter 10. And percent composition is used to identify an unknown compound if you know the percentages of the elements that are present in that compound, and you can compare them to known substances to figure out what the compound actually is. Percent compositions are also very useful to determine if an ore is worth mining. These are three examples of copper ores. They all contain a different amount of copper, and you can determine which of the three are going to yield the most copper should you mine them. So the formula is rather a simple one. To figure out the percent of the element that is present, you're going to take the mass of that element and divide it by the total mass of the compound times 100. So you will need a calculator and a periodic table. So if we take a look at sodium chloride, it's just composed of sodium and chlorine, one atom of each, and you would think that it would be 50% sodium and 50% chlorine. However, that's not the case when we are looking at masses of the elements that are present there. So we are going to determine the molar mass, which you know how to do. There's one sodium, one chlorine. You write those down. We use our periodic table to look up the atomic mass, and we want to round to one place past the decimal. So sodium rounds to 23.0. Chlorine rounds to 35.5. And since there's only one of each, we multiply. And it's very important that we maintain that one place past the decimal, the tenths position. And now we are going to add these two numbers up. This comes out to be 58.5 gram per 1 mole. So that's how many grams are in 1 mole of sodium chloride. So we're really interested in the total amount that we got for the sodium divided by the total amount for the compound. So for percent sodium, we're going to take the 23.0, divide by the total mass of the compound, 58.5, and multiply by 100. This comes out to be 39.3%. And we always want to label the substance we're working with. So that's sodium. So 39.3% sodium is the percentage of sodium in sodium chloride. So let's go and show the math for percent chlorine. We take what we got for a total for the chlorine, divide by the total of the compound, so 35.5 divided by 58.5 times 100. And that comes out to be 60.7% chlorine. So there's actually more chlorine by mass in just one formula unit of sodium chloride. Now you'll notice that these two percentages add up to 100%. In fact, it comes out to be 100 99.0%. So that's a great way to check to see if you've done your math right, if all of your percentages add up to 100%. Now, sometimes with rounding, we might get 99.9% or 100.1%, which is okay. I'm going to give a little bit of leeway on that, but anything beyond that, you're going to want to check your math. So let us, chemistry cat, do your homework or else. My science teacher threw sodium chloride at me. That's a salt. So do your homework. You don't want to be assaulted. Okay, so here we have a compound that has 3 elements in it. And again, we want to determine the molar mass. We write down our elements. We have 2 aluminum, total of 3 sulfurs, and 3 times 4 gives us 12 oxygen in aluminum sulfate. We're going to multiply by the atomic mass of the element, and we want to round to the 10th position. So aluminum's mass rounds to 27.0. Sulfur rounds to 32.1. And oxygen rounds to 16.0. So aluminum 2 times 27 is 54.0. 3 times 32.1 is 96.3. And 12 times 16 is 192.0. Add these numbers up. Comes out to be 342.3. And we're not so much interested in units at this time. We're just interested in the numbers here. So we want to figure out the percent aluminum, and we want to take the total amount of aluminum that we got. That's 54. Not the 27, but it's 54. And then we're going to divide by the total. So 54.0 divided by 342.3 times 100. That comes out to be 15.8%. And we always want to identify our substance. So we write a little AL next to it. And we're 1/3 of the way done. So let's determine percent sulfur. You want to take 96.3, the total amount of sulfur divided by the total mass of the compound. Remember to write times 100. And this comes out to be 28.1% sulfur. Okay, so let's show the math for the final percentage of oxygen. We want to take the 192 divided by our total mass of the compound. Times 100. and we get 56.1% oxygen. And if we total this up, it does come out to be 100.0%. So it's a great way to check to see if you have done your math right. So please show all of your work on your notes, just like I did here. And also on your worksheet, please show all the work before you submit it. Don't forget, I do have office hours from 10 to 11 a.m. and 1 to 2 p.m. Monday through Friday, and you can access those URL addresses for Google Meet. Paste them, copy them, paste them into your browser. They are found on my Schoology page. Have a great day, everyone.